Finally, Firebase is the most comprehensive developer offering we have done till date. I'm glad it's available today and look forward to hearing your feedback. We talked a lot today about machine learning and AI. We think there is an opportunity to accelerate computing by working on this with everyone else. And so we are trying to do that in two ways. First, we are opening up core components of our machine learning systems. Last year, we open sourced TensorFlow so that developers can embed machine learning and deep neural nets with a single API. In 2015, it was the most forked project on GitHub, and it is the #1 machine learning project on that site. Last week, we open sourced a natural language parser, which is also built on top of TensorFlow. We are doing these things so that we can engage the external community and work on this together with everyone. Second, for developers and companies out there, we are also exposing our machine learning capabilities through our Google Cloud Platform. We already have a cloud machine learning platform underway, and you get access to computer vision, speech, language, and translation APIs. And we are working on bringing many more machine learning APIs so that you can get access to the same great capabilities we have inside at Google. We believe this will be one of the biggest differentiators for the Google Cloud Platform over time. And by the way, when you use Google Cloud Platform, you not only get access to the great software we use internally, you get access to specialized hardware we build internally. And talking about that, for machine learning, the scale at which we need to do computing is incredible, and so we have started building specialized custom hardware. We call these tensor processing units, or TPUs. TPUs deliver an order of magnitude higher performance per watt than all commercially available GPUs and FPGAs. And when you use the Google Cloud Platform, you can take advantage of TPUs as well. TPUs are what powered AlphaGo, DeepMind's AlphaGo, in its game against Lei Sedol. Go is an ancient Chinese board game. It has a simple 19 by 19 grid, but it is one of the most complex games humans have ever designed. It has more possible board configurations, many more possible board configurations, than there are atoms in the universe. Beating Go for computers was widely considered to be the grand challenge for AI, and most people thought it wouldn't happen for another decade or so. So we are really thrilled that AlphaGo was able to achieve this milestone recently. One thing worth calling out, in the second game, there was a move 37 by AlphaGo. It changed the course of the game and is now widely considered one of the most beautiful Go moves ever seen in tournament play. It was not just an intuitive move, but a very creative move. We normally don't associate computers with making creative choices. And so to us, this represents a significant achievement in AI. By the way, Lei Sedol has won every single game since he played against AlphaGo, and he has even replayed some of the moves he learned from AlphaGo in that game. As the state-of-the-art capabilities in machine learning and AI progress, we see them becoming very versatile, and we think it applies to a wide range of fields. I want to give you two examples. First, robotics. At Google, a bunch of 20%ers decided to help trained robots to pick up objects. You can see it behind me. This is not new. You usually do it by writing control system code. You program the robots with rules. But this time, they decided to use deep learning techniques. So you create a continuous feedback cycle so that the robots can learn hand-eye coordination by themselves using deep learning. As you can see, they keep doing it, and they keep learning it over and over again. And over time, they get better, and they even learn natural and useful behaviors. So for example, the robot is nudging the stapler away to pick up that yellow object. We didn't write that rule. The robot learned it automatically using deep learning. So it's an amazing example of what machine learning can do. Another example in healthcare. Diabetic retinopathy is the fastest growing cause of blindness. It affects 4.2 million people in the US and many more worldwide. To detect it, you need to do a scan of the eye like you see behind me, and a highly trained doctor can detect it.